Hello and welcome back to Methodical Math. Today we're going to do more examples on finding terms of a sequence. So our given problem is a sub n equals 1 over n plus 1 naught. We're going to go ahead and pretend like that naught is not there for the first portion of this problem. Let's go ahead and find our first one, which is a sub 1. So we have a sub 1 equals, wherever I see n, I'm going to plug in a 1. 1 plus 1 naught will give me 1 over 2 naught. That is going to be our first term for now. Let's jump to a sub 2. This gives me 1 over 2 plus 1 naught. Parentheses. This gives me 1/3 naught. 1 over 3. A sub 3 gives me 1 over 3 plus 1, which gives me 1/4 naught. 1/4 naught. And we notice the pattern here. We are just adding 1 to the denominator, so we know our fourth term is going to be 1 over 5. All right. Now let's go ahead and clean this up. This cannot be our final answer, so we have to simplify. That means get rid of that exclamation point. So 1/2. This acts as recursion, so we are going to have 1/2 times itself since it's the first term. So let me rewrite out our sequence here. All right, so we know that our first one is going to be 1/2. All right, from here, a sub 2 equals 1/3, and we're going to go straight backwards. We're going to multiply that by the previous 1/2. So a sub 2 here is 1/6. Moving to the next term, a sub 3, which in this case is right here, we have 1 over 4 times, going backwards, 1 over 3 times 1 over 2. All right, so we're going to multiply all these up. This will give us 1 over 4 times 3 is 12. 12 times 2 is 24. 1/24. Our final term, a sub 4, which is right here, we're going to go 1/5 times, going straight backwards, 1/4 times 1/3 times 1/2. And this will give us 1 over 120. 1 over 120. And that is how we solve the equation with the naught symbol. The easiest way is to break it down like we did in this first step, and then go ahead and simplify once you have what a sub 1 and a sub 2 and so on is. All right, let's go ahead and move to another example here. We want to solve, let's set up our sequence. We're only going to find 4 terms. This one is a little different. We have given a sub 1 is 1. So we can go ahead and plug in 1 since this is a sub 1. And then we are given a of n plus 1 equals 5. And it's a of n minus 3. Okay, so from here, the first one always is the hardest. We were given a sub 1. So we know what this a sub 1 is. So we are looking now for a sub 2. So what I'm going to do, we plug in what we know. We know a sub 1. Go ahead and add 1, since that's given. 5, this will be a sub 1 minus 3. So in other words, this is a of 2, and you always want to keep a. Don't ever plug in what the actual sequence term is. We want the a, because we're trying to figure out what each consecutive term is going to be. So a sub 2 is the same thing as 5. A sub 1 is 1 here, so multiply by 1, subtract off 3. 5 times 3, or 5 times 1 is 5 minus 3 will give us 2. So a sub 2 equals 2. Let's move on. We just did a sub 2, so he's going to go right here, plus 1 equals 5 times a sub 2 minus 3. And we know we're doing this right because we are adding 1 to each a, so it's going to go a sub 1, a sub 2, a sub 3, and so on. So let's plug this in. We have ace of 3 now is 5 times what was ace of 2? It was 2. Multiply that by 2. Subtract off 3. 5 times 2 is 10 minus 3 gives us 7. 7. All right, one more to go. Our last one we used was ace of 3, so we're going to go ahead and plug in ace of 3 plus 1 is 5 times ace of 3 minus 3. Plugging what we know, this will make ace of 4 times 5 times ace of 3 was 7 minus 3. And this will give us 32. So we're going to plug in 32, and then this is our final sequence. All right, I hope this helps. If you have any questions, please leave them in the comments below. I'll do my best to answer all of them. And until next time.